Yeah. Look, honestly, ideally, it would be ideal to get out and check them at least once a year. Higher profile ones even more often. Honestly, the reality is that we probably get called out to go and audit these rain gardens for a council. They'll come and commission us as consultants to come and look at them. We'll be lucky if it's once every 3 or 5 years that they're doing a proper full audit and assessment of all their assets, where they really look at them in detail. That's the reality. What it means is that we're inspecting assets that were built 5 years ago, and they're what we call day one failures, because they filled everything up. It was filled up to the brim on the start, and on day one after construction, that asset had already failed. If someone had come and looked at it, when they finished building it, they'd have seen immediately that there was a problem. They could have said, need to fix this asset, go and fix it. If you bring us out 5 years later, then we lost 5 years when that asset could have been working. But honestly, every couple of years is probably enough. But if you can, you want to get out and just eyeball them more frequently, even if it's just a guy in a truck driving past and just checking and going, oh, there's an issue there, we've got to deal with that. It doesn't need to be a long inspection, and then maybe every year or every 2 years or 3 years, you have someone who's a consultant come and actually look at it and really thoroughly check everything and make sure it's all right.
Yeah.
So it's probably enough.
Yeah, but I feel like we have to do that often in Bangkok.
Yeah. Honestly, you probably need to do litter really frequently, and we do too. It depends where. Some parts of Melbourne, these things will fill up with rubbish in weeks, or more. I suspect you'll have similar challenges in Bangkok, that you'll find that the litter loads are challenging, and you need to be out there cleaning that out quite frequently. So,
Thank you.
yeah, and it's probably weeks, not years, for that.
About the bio retention, is the same thing with
Yeah. Biofilter, bioretention, rain garden, biopod, any other. There's a million names, they're all the same thing. It's plants, filter media, water soaking through it. So, I would note the US call them rain gardens, and they're often referring to systems where it's in a garden, in a backyard, and they don't put any under drainage in, they just let the water soak into the ground. So they're talking about the same thing, but if you're talking to someone in the US, that's what they're thinking in their head. If you're talking to someone in Australia, they're thinking of really sandy media and an outlet pipe, and where it goes through and drains out. So there are differences in the systems, but in Australia we're using biofilter, bioretention, rain garden interchangeably. So, hope that helps.
Do you line the bottom of the rain garden with anything different or do you expose those systems to the Melbourne soil?
Yeah, sometimes we will put a geotextile just to make it easier to get the material in. So we'll have one that lets the water through it, but we'll still use a geotextile so that we don't have clay or sand slumping into our system while we're building it. In the main, our company will try to design without any lining preventing water flow as much as possible, and there's two reasons for that. One is that we want to lose water. We want to get water into the landscape, we want to get it into the clay and not have it going to the waterway downstream. So if we can leave it unlined, we will. The second thing is that it means that the plants and trees can grow into that soil. If we put a tree in one of these and we line it, we're basically putting a tree in a pot plant, which means that that tree is only going to get as big as that pot plant lets it grow. If we can leave that liner out, then the tree can grow into the soils around it, and it can go as big and far as it wants, and it can go and find water wherever it needs to. And you'll get a much bigger tree, a much healthier tree. So, especially when we're putting trees in it, we won't line it if we can avoid it.
Thank you.
So, yeah. Which not everyone in practice will tell you.
try to compare, like pick the part that can be applied to Thailand.
Oh, okay. What things work? What things from here that you can take and apply there? So, what do you think is useful or not useful then?
In your system, when you want to use the rainstorm that you already harvest it in the tank underground, yes,
Yeah.
you need to pump again to use Oh.
use the water
Yeah,
for harvesting the water.
yeah.
Yeah, usually, yes. Usually you need to pump. So once the water's underground, you need to pump it to take it somewhere to use it. Yeah, unless you've got drainage deep enough to take it out. But usually once you put it in the storage, you'll have to pump. Yeah, which obviously has maintenance implications and all that. So, yeah. Yeah, but yeah, most stormwater harvesting systems have to pump somewhere. Sometimes we pump into the system to do the treatment. Sometimes we try to get gravity into the treatment and then we pump. So it just depends on where we're taking it from. What's best. So, yeah. Is most of your irrigation system runs by gravity? Is that correct?
Yes,
Yeah.
it's safe.
So,
Yeah.
yeah.
But sometimes in the hill or in the higher land,
Yeah.
we use the pump
You also have to
Yeah.
pump. Yeah. To get
by
the water.
electric or by the sun.
Yeah.
Solar.
Okay. Yep. Yep. Yeah. Yes. So it's probably worth saying that gravity systems are definitely preferred because one, they don't fail as easily, but two, they don't cost a lot for maintenance. So definitely wherever we can, we use gravity, and you'll see all the systems I've been showing you today are generally operating by gravity. But as we urbanise and it gets denser and more intense, we start to find that we do need to rely on hard infrastructure and on civil and mechanical and electrical systems more and more to make things work. But it brings with it a whole heap of reliability challenges. Yeah. As you know, a levee is good, but once you've put a floodgate in, then you've got the risk of that gate jamming or breaking or not turning on when you need it to. So it brings with it extra challenges. So a swale is another gravity system. Essentially, it's just a channel for conveying the stormwater, but with plants in it. So it's got grasses or it's got other vegetation in it. And the idea is that a swale is not just a drainage channel, but it's also there to provide some treatment of the stormwater by passing the water through the vegetation, and it can also help to absorb some of the water. So they're probably most commonly used either in a park setting or in beside a road is probably the two most common places that we'll use them. So a couple of examples, just letting the footpath and probably some of the houses drain into a swale drain here, picking that up, letting the water flow along, and then picking up any excess flows in the pit here. There's another example from China. So they really know how to make things look good. So when you're designing these things, think about not just function. As engineers, we've got to have a low have a low roughness so that the water can move quickly through and we can get it away as quick as possible. Well, think about the people too. So let's have some nice flowers, make it aesthetic. Still works. Water will flow in here. The water will still travel down it, still make its way out. Might flow a bit more slowly. Good. If it flows more slowly because it's flowing through the plants, that means it's getting better treatment. So it's not necessarily a bad thing. So different ways of doing it. Challenge we find with building swales next to roads is people always want to park next to the road and they keep driving their cars into our swales and get wheel ruts and all sorts of problems. So put bollards in to try and keep them out. We put rocks, we put all sorts of different things to try and stop them driving in there. Driveways are the second problem we hit, is that we try and put a swale in front of residential buildings, but they've got to so we've got to have a dip and then we've got to come back up again to make the swale work so that we've got the water flowing through, but they've got to drive from the road into their garage, and you can't have a dip like that because if they're driving their trailer or their caravan in and they go down and up like that, they're going to scrape their car as they're doing it and they're going to have all sorts of problems. So we've got all sorts of different ways of trying to get the cars across. But I'll be honest, these become blockage problems because stuff gets caught on these and it blocks up, and they become a bit of a maintenance pain and that sort of thing. So honestly, we're trying not to put swales where we've got lots and lots of driveways these days. So if we've just got houses all along the street with driveways, we don't generally go to swales as our preferred option. It's probably better to do a series of biofilters in between the driveways and break it up. Unless you're in a sort of semi-rural area, in which case you don't want gutter and everything, then we might still do a swale But in a more built up area, we're moving away from really trying to get swales into these sort of new housing estates, because it gets really challenging to make all of this work well. But where it does work well is down the side of the house, or where you've got industry, so your driveways aren't so frequent, or you've got a median strip, or somewhere where you don't have as many crossovers to deal with. So obviously it provides conveyance, water flows down the swale, we've got a depression that the water can drop into. It helps to filter the stormwater, and they're particularly good at removing sediment. So all the sediment will settle out as it passes through the grass and moves along it. So a bit of illustration. So it slows the water down as it's passing through the grass. Coarse sediment will settle out. Plants will help to uptake some of the nutrients, so we'll get some nutrient treatment while we're at it, a bit of heavy metals, and the water will soak into the soil, so we're getting that infiltration. So again, we're reducing volumes. And a small swale isn't going to do much, but where these actually work really well is if you look as you're travelling out here or as you're driving around tomorrow, have a look at the swales that are beside the roads. So we've got a channel, we need a channel anyway to pick up the water from the road and carry it away. So let's just vegetate that swale, nice and cheap, just put some grass in there, get the grades right so the water can drop into it. Sometimes that swale is half the size of the road catchment. And if it's that big, what it means is that most of the runoff from that road is now going into that swale, and it's not flowing to the end of it, it's soaking into the ground, it's watering the plants, watering the grass, and then that water is evapotranspiring back into the atmosphere, and it never even makes it to the end of the swale. So we've got a really low cost intervention. We use it anyway in rural areas in Australia. It's really low cost, but it's giving us treatment, it's giving us volume reduction. That's helping to reduce your combined sewer overflows at the bottom end of that system because you've absorbed that water before it got there. So we can put them in landscaped areas. This is one with a car park or something just draining into a swale around it in a more built up area. So a few things that we need to think about as we're designing these. One is we need to think about slope. Obviously you want some slope because we're trying to move the water from one location to the other. So we can't have it completely flat. The water's got to move. So if it's too flat, you'll get two problems. One is that the water will start to pull up and get caught in depressions and get stuck there. Second is you're going to get mosquitoes and then you're going to get people complaining. So we don't want them too flat. On the other hand, you don't want them too steep because if they're in a really steep grade, instead of sediment dropping out in the swale, what you're going to have is that the water flowing down the system where there's a break in the plants or any gaps, it's going to actually start to erode the sediment and start to carry it down through the system. So we've got to get that sort of balance of not too shallow, not too steep. So we need that kind of, what we'd say a moderate grade, let's say nominally at least 1% so that there's some grade there, not more than about 5%. If you get more than about 5%, you need to start putting some check dams in to break up the grade a bit. You need somewhere where there's plenty of space. So as I said, they work well next to roads, work well in median strips, work well in car parks, gardens, etc. And the other thing that they are really good for is as a pre-treatment. So let's say we've got one of those biofilters I showed you in a park. We've got water coming from an upstream catchment. If we can run that through a drainage channel and a swale before it gets to the biofilter, that will then help to catch a lot of the sediment before it gets into the biofilter and where we've got filter media that we want to protect from the sediment. We don't care if the sediment drops out in the swale, it's not stopping that from infiltrating and draining. It's probably similar soil anyway, but then it keeps the biofilter and protects that from getting blocked up. So that's a really good combination. Swale going into a biofilter can work quite well. They're also good in sort of smaller spaces where you can have just a really short or a small swale that then helps to filter that water before it then drops into a biofilter. So you might have a garden in a car park. The first bit of it's essentially a swale. Water flows off, goes through the swale, and then goes into the biofilter at the end of it. So good spots for swales. Where not to put a swale. Steep sites, obviously, really flat sites. And The other thing as our learning is not where you're going to have heaps of crossovers and heaps of interactions with the swale where everyone's going to want to park their car. So Lynbrook, which I mentioned, where we put our first biofilters, we also put swales in the side streets of Lynbrook. And the residents there hate them because they get boggy and they get messy when they drive their cars in there. And council hate them because the residents come and put soil in their swales and fill them in. They park their cars on them and they make a mess of them. So they're just a nuisance for everyone in that particular setting. So the other thing to think about is, can you physically get to it to maintain it? Because they work really well next to roads. But a narrow median strip can be a real pain to get to and maintain. So if you've got a really busy road, constant traffic going up and down it, you've got a 3 metre wide median strip in the middle, some poor guy's got to get in there with a mower and try and mow it, or you've got fencing in it, so he's got to get in and weed around the fencing. That then becomes a hazard. You've got to close the lane of the road while they're doing the mowing. So think about the maintenance when you're planning these and think, is this the right spot for a swale? Is it the right spot for a median strip? Sometimes it's better just to go without. So yeah, some of the common issues we see is that things are just too flat and we've got ponding, or we've got erosion. That's sort of common issues that we see. So that's it for swales. Any questions, thoughts, comments? Through that pretty quickly. So. They're not rocket science, are they? They're pretty simple. Just a depression, just form a depression in the ground, plant it out with plants. It's pretty much all you've got to do. So they're good because they're cheap. You can't get too many things wrong with them. As long as they're not eroding, they're not creating pools of water, you're pretty much okay.
So essentially it's a vegetated drainage channel.
Yep,
Yeah.
pretty much. Yeah, essentially. Yeah. And in some cases they've just got grass in them, you can come in and mow them. We like to put native veg in where we can, plant it out. One thing we try to discourage, people like to put a gravel trench in the middle of it or rocks down the middle of it and create a pilot channel. That's defeating the purpose. We want the water to spread out and we want it to go through the plants. So if you do that, all the water is going to concentrate through the middle, all the sediment's going to block up the channel anyway, and it's not going to actually give you as good treatment. So we try to discourage putting a pilot channel in the swale. But yeah, other than that, they're fairly idiot-proof, which is good, and they're fairly low cost. So they're a good solution from that point of view. On the flip side, they tend to take a bit of space, and they tend to be a bit more natural looking, so it's harder to get them into a really dense urban area. So they're not going to be the right solution everywhere. Question?
From the examples that we see from the slide, I have a question. Maybe like in the context between Australia and Thailand.
Yep.
In Thailand, we have the country, and we have urban area, residential area, and the farmland. Sort of separate, like farmland would be far in the countryside.
Yeah, well,
Is that the same case as in Australia?
so you won't have areas where you've got farmland and city quite close together? Or?
In the farmland, we don't have big city.
Yeah. So it's
Just
quite
maybe like
rural.
community,
Yeah.
small community.
Yeah, they're quite small communities. So in those areas, you probably already have swales because you don't have any formal drainage. I mean, you probably don't call them swales, but you probably just have sort of drainage channels, and if you're lucky, they've got some plants in.
No, the point that I'm getting into is that it seems like these system like wetland or the plant rain garden,
Yeah.
the swell things, mostly they are in the residential area. Do you have these systems like installed in farmland,
Oh, okay.
countryside somewhere outside.
So you're thinking about examples of what those might look like in a country or a rural area?
Right, because the area that we are responsible for mostly are in the
in the
countryside.
in the countryside.
yeah,
okay.
in national level.
Yeah. So you're dealing with countryside areas, small towns or small villages, as well as the Bangkok and the bigger urban
Yeah,
area.
most of the time, even the small villages are not. We are responsible for irrigation system, right?
Yeah.
Just irrigate to the
Trying to get irrigation to
To the
the farms.
things like that. Trying to get how can we like
Apply.
adapt
Yes.
How can you apply
to
some
our
things?
to our work.
Yeah. So you're responsible for irrigation in those areas, or are you also responsible for drainage and
Yes.
flood management as
Yes.
well in those areas? So how would you manage flooding in those areas? Is it generally managed through your channels and similar systems?
Irrigation canal and the main river.
Yeah.
Right.
The irrigation canals are
Concrete
are not.
canals, yeah.
At least the ones I've
some
seen,
some
like-
parts is like a earth canal.
Yeah.
And some parts is a concrete canal.
Yeah.
But for the duty of RID,
Yeah.
it's not responsibility to mitigate the flood in the town.
Yeah.
We responsibility to reduce the flood in the farmland.
Okay, so you're trying to manage flooding in the farm.
And if we apply like a wetland or rain garden in the field,
Yeah.
it may be, but who is need to pay for that because the farmer don't have the money.
Don't have money to pay,
Yeah, but if we use some like public area to collect the water from the rainstorm
Yeah.
and reduce the flood from the farmland,
Yeah.
it's our duty. It can be, but
Yeah.
we try to think that how we can apply in our organized something like that. Maybe you can suggest that.
I can think of the area that we can be responsible for, which is the big city,
Yeah.
like maybe Hat Yai,
Okay.
because we manage water in the whole system, the basin, in the river basin, and Hat Yai is like the end of the river basin go down to the sea,
Yeah.
right? Maybe like in some city, if we can reduce storm water from getting into the irrigation canal or major river that we manage,
Yeah.
it would be good so that we can manage less
Less
water
Yeah.
and reduce the possibility of flooding. So this thing can work, but then the organization responsible for the land in the city is the local municipality most of the time. Then maybe we can talk like to them and persuade them. Let's help manage this whole entire system. But then there are not that many cities that we can get in touch with. Partly Bangkok and surrounding area, Hat Yai in the south. I was just wondering if you have like some example from Australia case, or this thing, is it good to apply with the suburban or country area too?
So how can we take this very urban stuff and use it in a rural setting or a more country setting, essentially? Yeah. Good question. So you still have some of the same challenges. So you'll still have flooding in some of your rural areas. You'll still have water quality challenges. And if you're talking a water supply catchment because you're managing the catchments which are then coming into your dams. You said that volume is still an issue. So in some of your areas, so when you say irrigation channels, some of those you want to reduce volume going into them because you've got too much water and it's a problem. And when you say irrigation, is that really irrigation but also drainage channels?
Yes.
Because it's also providing a drainage function. Is that fair to say?
Can you explain? When we build the system from the beginning, it has to be decided whether irrigation or drainage because because the irrigation would be wider at the beginning and
Taper.
but the
Drainage
drainage
doesn't.
but most of the time nowadays when the flooding comes use the same system
It all goes through the same system.
or the canal that we have.
Everything that you've got. And in a sense, I mean, here in Australia, we try to separate and we have a water supply system and we have a sewer system and we have a drainage system and they're all nicely segregated, at least on paper. The reality is that it never works out neatly. But in Thailand, your systems are much more tightly integrated because you have a water supply dam, and that might then have towns or cities within the catchment, which is then contributing water into that. And you'll have drainage coming from them, you'll have wastewater coming from them going into your dam. And then downstream of that dam, that will have irrigation channels taking the water to the farms, bringing the water through the irrigation channels. But then you'll also have drainage channels, which are then taking the water from those farms and taking it away to try and deal with the flood water and carry that back into the main rivers and through the system. Is that sort of reasonable?
We don't always have the drainage. Most of the times are the irrigation system.
Primarily irrigation.
Primarily.
Okay. So, a couple of things. Biofilters, honestly, are going to be best suited to your urban areas in the city. So what you're doing in Bangkok, but also some of your other cities, they're generally going to be best suited to city areas. But swales is something that can go anywhere, so even in the rural areas, if you're looking at trying to reduce flooding or how to safely convey water along some of your roadways, a swale is an alternative to just having a concrete channel or just an earthen channel. What you can think about is, maybe instead of just digging a really deep earthen channel, maybe you can make that flatter, take a little bit more land, make it a vegetated swale. It's still carrying the water, it's still got quite substantial conveyance or carrying capacity, but then you can also get a little bit of treatment and a bit of water retention within the landscape, which might then help to manage some of your challenges downstream. So that's one option you can consider. Sorry, I should get some photos of these in rural towns too as well. So that's one possibility you can consider. The other thing is that the wetlands that I've shown you are primarily for treating stormwater that we've talked about today. But you also get nutrient runoff coming from agricultural areas. And we have the same problem here in Australia, that we have farms, especially intensive farming, that use a lot of fertiliser, and then we get nutrients coming off. And so if you go up to Queensland and think about the Great Barrier Reef, everyone knows the Great Barrier Reef, with all the coral, one of the problems we have is that we actually have a lot of farmland in Queensland, which then drains into the Great Barrier Reef. And so all the nutrients from that farmland wash into the Great Barrier Reef. So we actually have programs up there to try and manage the nutrient loads coming out into the Great Barrier Reef. So for example, sugarcane farms generate lots of fertiliser, and when they cut all the sugar, they cut all the cane, they used to just burn it all and leave the stubble and let all the sediment just get washed off. So we have big programs up there to try and reduce the amount of sediment and the amount of nutrients that are getting washed out into the Great Barrier Reef and Moreton Bay. One of the things that we're using to actually try and manage some of the runoff from the farms is that we're taking the wetlands, like the constructed wetlands that we're doing here, and we're adapting them to treat the water from the farmland. So there's no reason you can't take the systems that we're using here and build that at a farm scale so that it's capturing the runoff that's coming off the farm and then is providing treatment of the nutrients before it then discharges out to your drainage systems. Now, the challenge, as you said, is cost. Because the
And-
farmers don't have money for wetlands
And the area.
and the area.
Yeah, it's all occupied.
Yes.
So somebody has to
Something,
buy
yeah.
the land.
Yeah.
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 And
So there are your two challenges you'll have is land and
cost.
cost. And that's where you may have to consider who's benefiting from this. And if it's the broader community, that might mean that the government needs to come to the party with some of the costs. So we have programs here in Australia where we go out to farms, and the first thing we do is we say, can we look at your farm management and how you're using your farm and what you're trying to achieve? And then when you look at that, what you often find is that there's ways that you can help them improve the farm management so that they're using less fertiliser in the first place, because often they're putting too much on, and they're often putting too much water on at the wrong times. So the first thing we say is, can we look at how you're using water and fertiliser on the farm, and can we improve how you're managing that? Because if we can reduce the amount of water that they need for their crops by a quarter, then that means that when you get a drought, then they can continue to be productive and they continue to grow what they need to grow, but they're not using as much water. Obviously when it's wet, you don't care if they're using water, but when it's dry, you want them to use less water. So in the Murray-Darling Basin, we went through a period of drought from 1996 to 2010. We had very low rainfall for 15 years. The amount of water that we were using on farming dropped significantly through that period. And if you go on Google it and look up graphs, you'll see that the amount of water we were using in total, the amount of water per hectare was going like that. But the amount of production that we had coming out of the Murray and the amount of yield we were getting was actually staying flat, or it was going up for a lot of crops. And that was because our farmers had a crisis. They didn't have water and they had to figure out what to do. And so they worked out how to make do with less water. They worked out how to irrigate more efficiently. They put in soil moisture sensors and they laser graded paddocks so they were perfectly flat so that they could irrigate just the amount of water that they needed. They started to manage their fertiliser more carefully, so they're applying just as much as what they need, but they're applying it when they do need it. And so what we got is that we now use substantially less water, substantially less fertiliser, but we're able to achieve the same output. And that's a double benefit because the environment is better off, but the farmers are actually better off too, because now it costs them less for water, it costs them less for fertilisers, and when we go into a drought, they're able to sustain through those periods more readily. So I think if you want to look at your irrigation areas, probably the first thing to think about is, can you actually work with your farmers to help them improve what they're doing to reduce the impacts that it's having on your system, but also improve the outcomes for them. Are you already doing some things in that area? Do you already work with the farmers and some of the communities that you deal with? I assume you probably already are actively doing that.
All over the country.
So,
We have water user group
yeah,
all over the country.
yeah. So you have different water user groups and
Right.
you work with them. And you have irrigation districts, so you work together to manage the water through a certain district and make sure.
Regional offices,
Yeah.
O&M.
Yeah. So you're probably already doing a lot of this. So maybe.
I know, so like I'm just thinking about like drivers. So I know like, for example, there's another project that was funded or supported through the Australian Water Partnership, which was on reservoir water quality management. I'm not sure where it's at now, but I remember at the time the focus was on measuring the water quality in the reservoir, like creating an index, but wasn't really addressing the problem. So I guess maybe some of these approaches could address the problem of water quality going to the reservoirs, which I'm assuming is going to be used for different purposes.
I really don't know much about that project.
That project is emphasized for the sediment in the reservoir and also the weed in the reservoir.
Yeah.
Yeah, and when they collect the quality of the water, it's related with the weed. If more weed, the quality is bad or good, something like that.
Yeah,
because in RID have a standard
yeah,
of the water for the irrigation,
yeah,
and we found that if the weed is cover the surface under the water at the deep, the quality is not good.
gets
Low
it.
DO.
Yeah. Not treat like a fertilizer or just only check for the effect of the weed.
Yeah,
On the surface.
The fertilizer is the one who
We have a more weed.
Of course,
Yeah.
So I guess, well, Jamin's gonna talk a bit more, but I guess my point was like, it's good to know what your water quality is, but I guess some of these approaches can help address that issue potentially. I mean, that's just like, cause you were just mentioning like the issue about land and cost, but then there's also obviously the cost to the farmers or to RID of poor water quality. So like, I guess it's looking at that cost and benefit.
Well, the water quality that we have to maintain is not really, it's for the farming standard, not for household use. But we also sell, I mean the การประปาแล้ว water
Domestic authority.
public water the public water they buy water from our system, and that or the industry, when they buy water from our irrigation system, the water has to be
Treat by them.
They treat the water.
good enough.
Yeah.
Yeah.
Good enough.
Because the quality isn't so good. So
Because the price is very cheap anyway compared to the cost that they sell to people or the industry.
So you're supplying raw water
Raw water.
for agriculture, but not necessarily for drinking. But they'll still be getting that in their taps in the rural areas because that's the only supply they have.
Yeah, they have to treat. Right. But we maintain the quality of the water in the dam and reservoir that we are responsible.
Just I hope this is a fair representation of Haiyan. Right? You're talking about Haiyan, right? If you look at flooding here, right?
Yeah.
There's no point trying to do anything here. That's Haiyan City. It's more about pushing the flood mitigation upstream because it's a flash flood from the mountains.
Yes.
Right? It's the Haiyan case, my understanding. So if you look at this, right, you obviously have farmland on the flat terrain. You also have farmland on the slope. Okay, it's about what do you do on the farmland on the slope. Those people are planting pineapples or maybe teas, right, on the slope. So then, if you think the flood mitigation need to be happening here, and then if you look at the contours, if this is the contours, right, this is your drainage line. As far as I can see, when I visit Chiang Rai, people are doing nothing on the drainage line. That's why the runoff on the slope collected in the drainage line and then just rushing through. Okay? So what the farmers can do using Dale's concept is introducing swells here in the drainage line. And then if the drainage line is greater than 5%, introduce check dams. Okay? Check dams, slow it down. Why slow it down? Because at the end of their farmland, they can build a pond and wetlands right there. So then they can feed that water into the pineapple teas. So if every farmland is doing this, by the time the water reach here is substantially reduced in terms of velocity and volume.
Okay. Put another important factor in the figure. Hat Yai is a polder.
Yeah, but not upstream. Haiyan is polder, but Haiyan upstream is not polder.
Upstream is not polder, but a lot of water, a lot of rainfall from the mountain. This This system could help, but when it comes to the city, then it gets flood anyway because it's
in a
border.
Yeah, but
Yeah, but we can reduce.
yeah,
reduce
it's not
the
confusing
chance.
question, right? There are two questions. It's what do you do in the catchment?
Yeah.
And that's why you're asking in the rural area. Right? You're asking what we can do in the rural area.
Right.
There's plenty of things we can do in the urban. Right? Dale is talking about urban. Right? The question is what we do in the rural.
Right.
That's very important because if people just looking at this urban area, forgot about this. No matter what you do, it's not going to help you unless you increase the level of polders higher and higher. That's not what we want to do. It's in the rural areas, within the responsibility of RD, what we can do. And if you start introduced to the farmers benefit from this. Right? The swells help to slow the runoff down and help to feed into the crops in the base flow.
I have a question about the check dam.
Yeah.
It would work for relatively low flow, right? But this is flash flood, like 10 hours rainfall and come. And how would the check dam work?
It's a design question because it's better than nothing. We're comparing nothing. Currently, there's no check dams. Any
Right.
check dam will help.
The idea is they try to flow the water as quickly as possible to the sea.
No, that's wrong.
If the low tide, right? If the low tide, we deliver water as quickly as possible to the sea. Problem solved. 3 hours gone. 3 hours gone. Sometimes get rain at night, and our system overflow around 3 o'clock. 5 o'clock is all gone. It's quick. It comes very quickly, but then working with the check dam, we try to divert water out of the canal system, right?
No. It's not diverting. It's slowing down.
Slowing down.
Yeah. So
Yeah.
the check dam still have a low flow opening. The waters need to come through, but it's slowing that down.
Yeah.
But see, this is complicated, right? We have to break it down, right? If you talk about, are we talking about protecting the Huaya city or protecting the farm upstream? If you look at this city, right, the flood mitigation need to focus on the worst case scenario, which is high tide, okay, flash flood, and local rainfall. The flood mitigation design need to be for Huaya need to consider the three cases coincidentally happening at the same time.
Right.
That's the flood mitigation challenge you need to deal with. But for RD, this is the only thing you can do because this is not your responsibility. You can't do it. Unless they say RD to help them, then you need to think about high tide, local rainfall, and the flash flood happening at the same time. That will be a big challenge.
Yeah, we get blamed when it in part of the problem fixing. I mean, if there's any other possible solution, that would be good. So your idea is to manage upstream.
Yeah, you need to do things in every pass.
Right.
But this is what you can do here, and what you can do here, and what you can do here. Every base needs to apply some strategy, right? But they're different. Like if Huaya is polder, right, then we need to have a polder strategy, and the farmland need to have a slope strategy, and the flat farmland need to have another strategy. They need to work together if you want to protect this.
Okay.
Yeah, that's very important.
In your picture, this channel is like a natural channel or irrigation channel. The black one.
Yeah, that's irrigation canal.
This one.
Yeah.
The one,
No, the back one.
check dam. Check
That
dam.
you want to contact the check dam. This is natural channel or irrigation channel.
No, it's a nature drainage line. So it's on a slope, right?
Yeah.
It's the drainage line on a slope. Yeah.
I think it's really complicated. Hard to explain.
Yeah.
But I will try. If you say this is a natural channel in this area, correct?
Yeah.
This area is conservation area. This belonging with the forest department.
The farmland, that's
Yeah, you see the farmland at the hill. It's illegal.
Oh, it's illegal.
Illegal. Because this is conservation area. And the farmer cultivate in the illegal area.
Okay.
And if we come to promote them to do like this, it's also illegal. This is very complicated. that we try to think that this one it can use and relate. That we will have a class in Thailand. If the class the people come to join to join study, but they think, okay, I know that, but I can't do it. It not continue. You understand me? Because I done another cooperation about the fixed rate for the friendly with the irrigation structure. And we easy to explain my board because the law in Thailand say that it must have. That means that our staff ID must know how to design that. It's easy. But when the people from the designer come to join with me at the training, now I learned it 2 years ago. Now he's still thinking that it's necessary. He come to training, but when he back to the office and need to design, he think that it's necessary. Why you need something like that? It means that in the future our training will back to the Thailand and our staff will join. If we can explain them what is useful or what is used for our duty, they just come to train, but it not continue. I think that we try to think which one is related with our duty, something like that. And we need to decide our course. What thing we need to teach them, and they think it's useful for his duty.
Can I have a question?
Sure.
Is it a recreational part being
It's
some?
a forest reserve.
I my question is, for instance, you have a catchment
Yes.
project, right? So the question is like, is a recreational objective can be one of indicator, or like you do EIA, right? Environmental impact assessment. Is it possible to kind of, for instance, you already have like typical section of the catchment basin and the irrigation channel is all concrete. Is it possible to think like
You cannot have any infrastructure project in the forest reserve area.
No. I mean. Also, sorry. I just want to back to the original question whenพี่ลูกน้ำ mentioned that how you can like integrate this design. I just back to the very simple, like, is it possible to just like change the section to be some part of it? This can be more biodiversity. You can claim that the impact EIA, environmental impact assessment, you can say that you construct the line of the irrigation channel, but you reduce to use like concrete instead of some part of it. It can be kind of more vegetation, use the wetland, kind of the native plant in the area. Is that possible to?
I have to answer to that. First of all, what is the objective of that project?
Yeah.
Right? If it's if it is meant to be for water drainage as quick as possible, then has to stick to that. If it's for irrigation, then there might be some possibility. Second answer is that you have to quantify. I think personally, you have to quantify the BC ratio, the benefit of biodiversity, recreation, whatever, and then we have to try to convince ONWR and อะไรนะสภาพัฒน์ ON ไม่ใช่ ON ไม่ใช่ ON
ไม่เป็นไร
ไม่สภาพัฒน์ yeah we have to convince them that this value really relate to the project objective that we are doing
So that's perfect. So you can because you can claim that they are less impact in environmental if you use like more natural kind of section. Is that am I correct? No.
You have to compare with and without, right?
With
these features, how would it make
Okay.
Also,
BIA
we have to
better?
do the
My
measure.
answer, easy answer is can do along our irrigation canal. Either in this time maybe to along the canal is concrete, and we put this system in our canal some part and change like yesterday Mr. Chen Bin said change some part to use like biodiversity channel, something like that. It can be in our responsibility area, but you need to explain the budget value. I mean, this part, what is the useful of this part?
benefit?
Yeah.
Cost.
If this part, the อะไรประโยชน์อะ
The benefit.
the benefit ลืม the benefit of this part to solve the quality of the water. They said it's not your duty. I don't give the money to you to do that. But if you can explain them, the benefit is from the farmer, it's for the like this. The benefit is for the reduce the flood or can have more water in dry season, and the farmer can get more water because we already harvest this the budget value. Okay, this is your duty. You can do that.
We cannot do just because we want to do it.
I see.
Because I can show you example that in Phuket area, this is the island in the southern part of Thailand, is have a problem about lack of domestic water use, and we study to construction the underground dam before the water come to the sea, and we already study and have the EIA already. When I get this project to the budget value, they ask me what is the purpose of underground dam, objective of the underground dam. We said it collect the water for the domestic use. It's not your duty because your duty is water for the farmland. Don't do that. We don't have we don't get the budget. This is I tried to explain yesterday, but we think that how to apply and relate with our duty.
Which
Like
is
this.
irrigation, supply, and flooding.
Yeah.
I have two ideas to share. How can we apply this to the irrigation? To ID. Can I use the whiteboard?
So no, look, we'll send you some photos. This, if you consider this is the farmer in Australia, this is what people do. Along their drainage lines, they build swell and also trees because that's where the water goes. And then they finish up with a pond over there, and they can build a cafe next to it. So that's what you ask the rural community. That's what they do here, because we don't have water.
Yeah.
We don't have enough water.
Yeah.
I will send you some photos.
About irrigation project, I wrote it. This is river and this is a flow line. When we made the irrigation project, we choose make the headwork here, maybe the weir or something like that, and
We have a canal.
made the canal like this. It's a main canal.
สมกับออกแบบ
ว่าเขา
มีซิมโบลถูกต้อง
Yeah. And here. And here. Upstream, downstream. And we have the lateral here. Main canal, sub canal.
Okay, so,
Yeah. Main canal and sub canal.
okay. And then this is the first one.
Okay. Like this. Like this. And here. And make some like this.
Yeah.
Okay. So
เปลี่ยนสีด้วย
we have fountain out here. Fountain out here.
Is that pumps or is that gravity?
Maybe the regulator, small regulator. Okay, and this is a farm land.
ครับ
system เลย
That means when we deliver the water to the farm, we open the gate here. The water flow in the main canal and go to the sub canal. Water come to this. We open the
ครับถึงแล้ว
fountain out to the farm. And when in this we have the drainage
ซิสเต็ม
system here. Rainwater flow from the farm. Here is the lower land, and the water is over demand will come to this drain canal and go to back to the river. The first one is
So that's drainage, not irrigation then.
the drainage. Okay. Maybe the water for over demand have a fertilizer or chemical for farm. We can use something like this and soil here, wetland here, treat before let it down in the river. The first one. And the second, the good water for main canal before go to this. We make sure that good quality too. Something like that. We can make something like this.
Yeah.
Two options like this. This can
Will that already be good quality water because that's your irrigation water coming from the dam primarily, or it might have some? You might do your irrigation and your drainage systems overlap. So is drainage water coming back into your irrigation channels?
Yes, we have to check the quality before back to the natural river,
It goes back. Yeah.
but not it is some parameter like BOD,
yeah
DO.
DO and maybe pesticide yeah
Okay.
I think
not all dam but in
Not
a
everything,
new
yeah.
dam and the last dam
Okay.
Okay.
Alright.
All I want to share.
Thank you.
and
This is great.
and this one if like we can harvest more water maybe underground or something like that.
Yes.
And the farmer can reuse it in the dry season.
Yeah.
It will get the second benefit, something like that.
Stay here, because this is one step forward, a very important step, and then eventually you can educate the farmers because they are still using flood irrigation, right? That's why you have drainage.
Yeah.
Right? They either flood irrigation or they over irrigate,
Yeah.
and they create an agricultural runoff.
Yeah.
But over long term,
Mhm.
it's good for each of the farmland to be self-contained, which means that each of them are building a wetland on their own land.
Yeah.
So those runoff actually collect in their own land and recycle back. That's ultimately how you reduce the pollution. Because to be fair for the farmers downstream, right? They all need to play a role. They cannot discharge their agricultural pollution into the river, right? So that's a really good interim strategy. But long term, each one of them should have their self-contained system.
Another tool, if NBS could help, something like Spong City, we can absorb water in the land, and because in Thailand in the wet season it's really wet, and then it stops raining. If farmer can squeeze water back to work in the dry season.
Yeah, that will help. I think this is a good system and a good approach because you can treat the water here. The other thing you could think about is that if this water is treated, you could possibly add on to that that you could have the water pass into a wetland, but then you might have it going into some kind of storage pond there, which means that you could then retain some of the water there, and then that can be pumped back to the farmers in the dry season.
Yeah.
Now, you own the drainage channels, is that correct? That's the department own the channels?
Yes.
Do you own the drainage channels? So you own that land? So you could put swales on those channels without any difficulty?
Yeah.
You could do that now?
There's no land, it's just
It's very narrow, yeah. So you'd be constrained. So if you wanted to put storage, you would have to purchase land from the farmers, or you would have to negotiate with them to take some of that land.
If we can have something that contain a lot of water and use small land, that would be great.
It's called a deep reservoir. Easier said than done there. Yeah. So there's some possibilities here. The other way to think about it is that we're trying to hold water in the landscape with all this stuff we're talking about. We're trying to retain water in the landscape and then release it slowly. Your farms are already doing that. They're actually kind of like a giant nature-based solution system in their own right, because you're taking all the water coming from the runoff from the river here, you're spreading and distributing it across the land, letting it soak into the land, you're holding it in the land. Would it be fair to say these farms that we're talking about here, is that the farms here on the flat areas rather than the farms up in the forested, or is this also on the slopes?
Everywhere.
Everywhere? Yeah.
I mean,
So some are on the slopes, some are on the flat areas.
Not on the slopes, but more on the flat area.
On the fact.
Quite flat.
Mostly on the flat areas. Yeah. But in essence, these farmers are actually all contributing to helping to retain some of the floodwater in this space, and that's helping to protect the city from flooding now. So you've actually got a pretty good system already.
Yeah, the thing is, it doesn't protect flooding to
It's
the
not going to stop.
town.
But it's not going to stop it, but it's actually reducing it. Just think, imagine if all this farmland turned into a city and you developed that, what would happen?
No, it doesn't work with flash flood.
Yeah.
Hat Yai is a special place because
It comes off the mountains.
right,
Yeah.
and
So-
with not very far distance
Yeah.
to the city.
So when you say flash flood, is that when it rains on the city, or when it rains in the mountains, but then the water travels very quickly because you've got steep slopes?
Right, it actually
and
rains
water's not retained in this
everywhere.
area.
It rains everywhere.
Rain everywhere.
Rains
non-stop.
everywhere. Yeah, you get a monsoon and everything's under.
18
But
hours.
a lot of the water's coming from these upstream areas, is it? From the mountain
Right.
areas.
Because we don't have reservoir or any container.
Any kind of dam.
Yeah.
Yeah. But you have some headworks here. You don't have any dams on this particular system.
I'm sorry.
You don't have any dam on. You don't have any dam
No,
on the system.
because it's natural forest.
Yeah.
We
Yeah.
cannot construct.
So so you can't touch this area as that's natural forest. So this area is meant to be natural forest, and no one's meant to be farming it, but people are farming it. Yeah.
Disorganized.
It's long time ago,
And
and they said they do the farm before the law is occurred.
But they cut trees.
Yeah.
They cut.
Yeah,
Yeah.
cut tree, so we cannot cut tree.
so have you looked at what happens in the forest? What percentage of this area is being farmed versus what is forested? Have you mapped this within the catchment so you understand how much is being farmed and how much is forest? You've got that, so you know what proportions.
Yeah.
Have you looked at the hydrology to understand how much water
Yes,
is
we
being
know
absorbed
that.
by forested areas versus farming?
Yes.
And there's a pretty big difference, I'm guessing. Is that?
We try to put the concept of the check dam
Yeah.
in this area, but the duty belonging with another department. you know, because his area something like that.
Yeah.
That thing that we try to think that it's possible to use from the Mr. J project. That this is the Chao Phraya River. This is Bangkok, BKK, and this area is another province, Ayutthaya, and the flood come from the north, and have a problem in this area because the Chao Phraya River is come to narrow in this area, and Mr. J now his project construction like a bypass to reduce the peak. Like this come to 2000 and this only 18 and divert some part. This how long of this canal? 22 kilometers. And when conduct this bypass, we need to buy the land from the farmer or the and it's limited that the queue is not enough for us. Maybe only we can buy the land only 200 something like that. But if we can put like this system in this canal and can increase to reduce the peak 2,000 to 500 something like that by storage the water in the ground something like that, like this.
Water retention.
Yeah.
Water retention, detention.
Maybe can be help this problem. Is possible?
So your peak is 200. How long does that persist for? How long do you have to be shifting 200?
100 kilometers.
100 kilometers.
Yes,
And
22 kilometers off.
Okay.
Along the channel.
And just put out here upstream of Bangkok.
Yeah.
Comes out upstream of Bangkok.
Yeah.
Yeah.
So we're solving the flooding problem here,
Yeah.
but we're moving it
Yeah.
to here. So there's now a bigger problem for Bangkok to deal with that water.
The capacity is bigger. Capacity in Bangkok is like 2007.
Like in Bangkok, has a high wall. High wall, and the capacity is nearly 1,000 something like that. And we call it this is sea, Gulf of Thailand. We have some diversion canal again to release the water very quick to the sea. It's no problem. We think that if can input, it's no problem about
No, this water and this bypass water is the same water, but it is not the same time.
Because water is traveling through the system, it takes time
Yes,
to go
direct.
through the system.
And this bypass will make the time.
How long does it take water from here to get to Bangkok?
One day,
Yeah.
1 or 2 days.
Around one day.
How long does it take to get from the hills, mountains
2 days.
to this area?
2 days.
2 days.
It's a long system.
So, if we accelerate how quickly this water comes through here,
Yeah,
so it comes through faster, that will help to alleviate the problem here.
yeah.
But it's going to put more pressure on the system.
Uh-huh.
Now, at the moment, this pressure system can handle it because it's got more capacity.
Okay.
But if we have tidal problems here,
Mhm.
we can't get water out,
Uh-huh.
and we have flooding here, and then the flooding here,
Yeah,
and everything hits at once,
Mhm.
we're going to have a problem in Bangkok.
yeah.
So we want more capacity at the bottom end to get water out quickly,
Mhm.
but ideally we want to slow down the water that's coming from the top of the catchment as much as we can.
Yeah, yeah.
Because if we can make this take, say, another 24 hours,
Mhm.
that will give us time to clear the water down here out of the
Okay.
system. So we want to slow the water down up here,
Yeah,
and we want to speed the water up down here,
yeah.
ideally.
Okay.
That catchment is larger than Victoria. It's double the size of Victoria. Yeah.
So it's huge.
4 times of
Very
Victoria.
large, yeah.
Yeah.
So, I mean, this is a certain peak
It's
flow.
huge. Yeah.
Yeah, this is a certain peak flow, but the challenge is also the volume, because this is over 24 hours, so it's a very, very large volume of water that you're trying to deal with.
Yeah.
Yeah, and this one is not flash flood.
Yeah.
It is like 2 months.
River flow that goes for a long time. Yeah,
So what we want to do is reduce queue,
Yeah.
reduce quantity,
Reduce the peak.
not only slow down.
yeah, yeah. Okay.
But Jay, were you at the based at the construction site office of that project?
Yes.
Because I visited that project last year. You were there?
Oh,
It's me.
Yeah.
I mean, I can remember you because there are 550 people in the room. I was there with Aksara.
but I'm in the center, but I don't go to the.
Oh no, but I saw this being constructed.
Yeah.
Yeah.
I mean, now I fully understand why. Because the translation is very bad. I couldn't fully understand the purpose of the canal. But I think it has to do with how you operate it of the bypass. I mean,
เดี๋ยวจึงไม่มีส่วนร่วม โยนให้จึงอ่ะ
because you're building a 22 kilometer long bypass, right?
Yeah, yeah.
If the bypass is purely used as a conveyance canal, it is not used to its full capacity. Because you will have if you look at the cross section of that canal,
Uh-huh.
you have a normal water level,
Uh-huh.
right?
Uh-huh.
Which is determined by the upstreams of Jopia, right? And then you have top water level. It's limited by this levee, right? Because you can't flood with the neighbors. You build this wall. This is the capacity you are conveying, right? You can only use this space because that water is the dead zone. That's not moving. It is stay there. That's normal water level. That's your tail. That's the tail water level. That's the head water level.
อย่างนั้นเหรอ
So the normal water level, jump in and saying that's at the tail water of the outlet, so you can't move through.
Right?
Because it's still capacity, because water
Yeah,
is
yeah, we can release all the water,
release all the water.
but for the O&M, we need to store water in the canal for protect the slope tracking in the dry season.
Yeah. I mean
Yeah.
that depends how we design, right?
Uh-huh.
So if we design a terrace, that will solve that problem. Right? Because it's about how do you use the full capacity of this diversion canal. Right?
Yeah.
So let's say if you design it this way, right, it's stable, even though it's empty, it won't collapse, right?
Yeah.
Because you have this. And then in the peak flow, because at upstream you can monitor where
Yeah,
the peak
yeah,
come, preemptive pump this.
Yeah.
So completely empty.
Uh-huh.
And that, first of all, we use this as a retarding basin.
Yeah.
And then open up as a passage.
Yeah.
So you use the same thing twice.
I understand your thing.
Yeah.
But if we design, Mr. Joke design canal lighting,
Yeah.
this system is not occur. Because you need to
By
compromise the old land. Because if you design more slope, it means that your canal is very wide. And many people have a problem that they will lose the land. This is why we try to use limited of the land for the canal. Yes, we know that if we design the slope lighting, we can protect the sliding. But we have the problem, and this system is no way, don't come. This is my land. Go. Let's go.
This area is very soft soil. It's something like silt.
Yeah.
In this area,
along this layout and farmland, and sometimes it's a town.
we improve by soil cement column
Yeah.
for protect the side slope.
So you just cement stabilizing it.
Yes.
You're not building it concrete channel,
Because
just stabilizing.
we have to
เราทำเป็น
make the canal
มีแค่
over
ช่อง
the
เดียวประมาณ2 กิโล
higher than the ground
ground.
เซกชันก็เป็นอย่างเงี้ย
This one is higher than the ground.
Yeah, higher than the ground. Oh,
Yes.
so it's elevated.
ใหญ่เมตร
It's like a wall.
It's like,
อันนี้
so we use the soil cement column to protect the side slope, and for the bank we use the bearing unit, the small pipe,
cheap pipe
small concrete
มี
pipe
เพิ่มกี่ชั้น เป็นสองชั้น
ตอกอะไรวะ
เป็นสองชั้น
along the bank
Yeah.
for the car moving transportation.
Oh, yeah.
So we have limit the area
จริงๆ 2.5
for make the canal, and the soil is not really good.
Sorry, so the canal was sunken into the ground, or is it elevated
Some
above?
in the ground and some over the ground.
Okay, depending, because the ground is up and down, but you want to
Cut and
keep
fill.
it a constant grade.
Yeah.
I mean, we should talk. I mean, apparently this is too late, right? But we should talk about it in the design students maybe. It's how future bypass can be designed in a different way,
Yeah. Oh.
right? Because the total land uptake I already have to buy is this area, right?
Yeah.
And the other option is you buy a narrow bypass, but have a very large retarding area. So you end up buying the same amount of total land, but in a different two different forms. One is wide, long. One is narrow, but have a big retarding area. Right? So there's those are two. But with the retarding, we actually help reduce the peak. That one, once the gate fully open, is only bypassing, not reducing the peak. Right?
Yeah.
Right. So if this is one of the future scenarios, then this gives us the opportunity to introduce the lake, wetlands, all kinds of water harvesting. Right? Because we actually reduce the peak by doing so. So we can talk about it in one of the future
ใช้หน้า
projects.
ภาษาไทยมันทำยัง
ยัง
I think it's not too late. I mean it is not this project, because in the future on the right left hand side
right
we have light
Let's
left hand side we have two bypass, and now it's still in design process.
Yeah.
If we can put like this in the another project in the future, maybe it can help, because that I mentioned that it's 2,500 something,
Yeah.
that it's only 800, and we need more another side. And if we can put that, you said that put the wasteland or in our system, it can be. Okay, it's not late. Right? but we try if we have a target.
Yeah.
That we try to adapt this system in the bypass. Our team can do that, and it's our duty.
So we have to buy more land and make it the wetland, right? Construct it.
The total land is the same.
Total is same, but
Large at the beginning and the small.
he reduced to buy the canal with less than design, and the exit by the wetland for the wetland something like that.
One big piece of land instead of along.
So essentially what you're balancing there is how much storage you need to hold the water to capture the peak and absorb some of the volume, but how long you've got to hold that for versus the size of the discharge. So this might be 200 cubic meters per second with no storage at the top end of it, or it might be 100 cubic meters a second, but you might then need, I don't know, 50 megalitres or 500 megalitres of storage at the start of it. So there'll be a relationship between the two. This is a very large scale that you're talking with, and I suspect that the storage you need here is going to be very large because of the sheer size of your catchment.
Two villages.
Sorry?
2 villages.
2 villages, yeah, probably something like that.
Oh no, because some part of the canal is like a public land. We can put not only one big lake. You can put small there, here along the canal.
You know what RD should do to save your money, right? Is to buy a series of them, right? Look for the cheap land along this corridor, right? Cheap land. not single just build one, but we can build a series of retarding basins based on where the land is vacant. It's cheap. Right? But the idea is the same. Is how you create the savings. So it goes to your bonus.
No, one his previous division create the project. The land gets higher price already.
Or anyone needs the news?
No problem. No problem because I know if we have in the future I will buy along. It's my own land.
ความจริงมาพูดเล่น
Okay, shall we have lunch? Lunch is the.
No, I think this is great because we need to understand what the issues are that we're trying to solve and the challenges. And I think this fits well. I mean, really your challenges are that how do we get flood mitigation when you've got so much water coming through the system, and how do we balance the timing of flows, the volumes of flow that you're dealing with. I think that's good. So let's pick that discussion up when we come back from lunch.
Okay, thank you.
Thank you.
Thank you, Dale.